In this video, we're going to talk about solving polynomial equations by factoring. So far we've just talked about factoring them, polynomials, but now we're going to go ahead and include it and mix it in with the problems where we're solving for a value of x or y. We're really trying to get the value of a single variable. So notice now that we're talking about equations, so there do have to be equal signs. And again, your answer should be something like x equals or y equals or w equals. All right. So the first thing I want to highlight here is something called the zero product property. Woo. All right, so the zero product property says that if you have A times a B equals 0, either A has to be 0 or B has to be 0, or they both have to be 0. There's no way to multiply two numbers and get 0 unless at least one of them was 0 in the first place. Now, why is that helpful? Well, because if I have something like x plus 1 times x minus 4 equals 0, that means either x plus 1 or x minus 4 had to be 0 in order for that to work. So what I do is I set each of those factors equal to 0. X plus 1 equals 0. How do I solve that? Well, I just subtract 1 on both sides. And how do I solve x minus 4 equals 0? I'm going to add 4 to both sides. And so that gives me x equals negative 1 or x equals 4. Those are two possible solutions to the equation. And you'll notice that if you plug them back into the original equation, so you plug in negative 1 into each x value, it comes out to 0 equals 0. Woo! And if you plug 4 into each equation, or into each x value in the equation, it'll also come out to 0 equals 0. Notice here that I'm showing not just the substitution in, I'm also identifying at the very beginning x equals negative 1. Before I do the substitution, I'm labeling which one I'm checking. Okay. Also, I'm showing the full workout. So I'm actually showing negative 1 plus 1 is 0. Negative 1 minus 4 is negative 5. 0 times negative 5 is 0. I'm going all the way down. I'm simplifying completely. And I put a question mark on the equal signs while I'm checking until the two sides are absolutely the same, at which point I put a check mark above the equal sign. I repeat over here again. I label which one I'm checking. I substitute it in. I show every step of the evaluation with a question mark or the equal sign until the two sides are exactly the same. Then I put a check mark. This is the appropriate way to show your work when checking your answers. All right, let's try another one. If I gave you 5n minus 2 times 6n minus 1 equals 0, well, again, if I have two things that multiply to 0, at least one of them had to equal 0. So I set them individually equal to 0. 5n minus 2 equals 0, 6n minus 1 equals 0, and I solve. For 5n minus 2, I'm going to add the 2 over, and then I'm going to divide by 5. Then for 6n minus 1, I'm going to add the 1 over, and then I will divide by 6. So I get that n could be 2/5 or 1/6. I want to check these answers. So I start by checking n equals 2/5. I substitute that into the original equation. I simplify it completely, showing my work all along the way, and I see that the two sides do match. Then I check n equals 1/6. I plug it into every place that there is an n. I simplify completely, and I show that the two sides do indeed match. Now, what happens though if I'm given an equation like this, x squared plus 2x minus 8, where equals 0, where it's not already in factored format? Well, that just means that you have to do the factoring in this case. So what two numbers multiply to negative 8 and add to 2? Well, I know that, well, first of all, right in standard form, already in standard form, okay? I know that 4 and negative 2 multiply to negative 8, and 4 plus negative 2 equals positive 2. So now I factored it. I can set each of my factors equal to 0. I can solve. X equals negative 4, x equals 2. And then I check. I substitute x equals negative 4 in. It works. I substitute x equals 2 in. It works. All right. Let's try one that looks like this. Now, again, you'll notice I technically skipped over the first step in the last question because the first step is to make sure that it's in standard form to start with. And this is not in standard form. And the reason why I know that is because it doesn't equal 0. If your polynomial equation doesn't equal 0, your very first step should always be to move everything to the left side. I do recommend the left side because it's, prettier that way. But it can actually be either side. So in this case, because it equals 25, I'm going to subtract 25 on both sides. Okay? Now I can factor this. And when I look at this, I realize that it is in a difference of squares format. 144q squared is a perfect square. It's 12q squared. And 25 is 5 squared. So I can rewrite this as 12q minus 5 times 12q plus 5. Now, since it equals 0, and again, you'll notice I'm carrying that equals 0 down. Even though in that step, I was just doing the factoring, I always carry the equals 0 down. Otherwise, it's not an equation for me to solve. I'm going to set each of my factors equal to 0. I'm going to add 5 and divide by 2 for 12 for the first one. I'm going to subtract 5 and divide by 12 for the second one. And I get my two values, and I definitely make sure that I check them. Okay? So what about something like this, though? 3x minus 8 times x minus 1 equals 3x. Well, is that in standard form? Absolutely not. So first of all, it doesn't equal 0. So I'm like, okay, well, I need to subtract 3x over. Ooh, but I can't combine like terms when something's written out like that. So what I'm going to do in this case is I'm actually going to start by multiplying out the left side. So 3x minus 8 times x minus 1, when you FOIL and you combine like terms, it becomes 3x squared minus 11x plus 8. Now I can subtract the 3x over, and it becomes 3x squared minus 14x plus 8 equals 0. And so that is in my standard form. So I have something where it's written like ax squared plus bx plus c equals 0. I can continue by factoring. So looking at this, my leading coefficient is not 1. So I'm going to use my AC method. And when I do that, so, 3 times 8 is 24, and then I'm trying to find two numbers that multiply to that and add to negative 14, and I go through the whole rigmarole, I factor by grouping, I'm going to get 3x minus 2 times x minus 4, and again, it equals 0. Because it equals 0, I can set each of my factors equal to 0. 3x minus 2 equals 0, x minus 4 equals 0. When I solve for x in each one, I'm going to get 2/3, and I'm going to get 4. I do want to check my answers as usual, and I make sure to plug it back into my original equation, okay? Always check your answer in your original equation, not some modified version, because if you made a mistake getting to your modified version, you won't catch it otherwise. And just a reminder, when you check your answer, the purpose of checking your answer is to make sure that you got it right. So if you're plugging it back into the original and it's not working, that means you do need to try the problem again. It's not check it, say, oh, it didn't work, and move on, okay? You wouldn't do that. All right, let's take a look at another question. In this one, first of all, you'll recognize it's not in standard form. It's not all on one side. So I'm going to start by subtracting my 60m squared over. And notice that I am putting it in decreasing exponent order. So my m cubed comes before my m squared, comes before my m. Now, the next thing I want to recognize here is that there is a greatest common factor. I can pull an m out of each and every term. So I do. And that leaves me with 9m squared minus 60m plus 100 on the inside. That's a quadratic where the leading coefficient is not 1. So I'm going to use my AC method. All right. And when I do that, I actually see that it's a perfect square trinomial. Okay. So I have m times 3m minus 10 times 3m minus 10 equals 0. I'm going to use my zero product property. Now, 3m minus 10 equals 0 is actually repeated twice. So I'm really just going to do the work once. Okay. But when I solve this, I get m equals 0 and m equals 10/3. And again, notice I'm really getting 10/3 twice. Do I write it the second time? Probably not. So when I check my answers, I'm really just checking 0 and I'm checking 10/3. And just recognize that if an answer is repeated, we call it a multiplicity. So in this case, m equals 10/3 has a multiplicity of 2 because it comes out as an answer twice. Now that is, again, how you solve polynomial equations by factoring.